Hello, welcome to yet another revision stream. It's been about 2 weeks since I've done one of these. Honestly, a lot has been going on, but I'm beginning to get back into the vibe of, coming home from school. It's nice and sunny. It's revision season, and if I look over at my calendar now, we have exactly one, two, three. We have exactly 4 school weeks left. We have 6 weeks, two of them in the holidays. So we will have exactly 20 school days left before A levels, which is terrifying. I honestly feel insanely underprepared. I have been doing past papers in biology, and I've been averaging between 60% and kind of 70%, which I'm happy with. That's very good. But in history, it's all over the place, really. Apparently, my exam responses are good, but I need more practice. I feel very underprepared. So, we're doing not history, we're doing biology today. My brain is a mush. I do apologize. So I think what we'll probably do is just take a look at some past paper style questions, just see what we can kind of cook up in terms of things that we need to revise, because there's one or two things I want to quickly revise. One of them being transpiration and the other being translocation. Because I don't recall these processes. I want to start with translocation. And this is going to be my best bet of how it works. You got the xylem, the phloem. You got like your companion cells. And you have your sink. So, how does this process work? If we were doing this in an exam, it's likely going to be worth 3 or 4 marks. So what I'm pretty sure happens is the things like sucrose, like sugars. Sugars are gonna move out of the cell. I'm gonna guess via diffusion and not active transport. And we can call this the source. I remember that, the source and the sink. This is going to do something in relation to pressure gradients, I believe. Because it decreases the... Sugars are soluble. So it's gonna increase Oh no, I don't remember. Either way, I remember that water is going to move in via osmosis. This is going to lead to a high hydrostatic pressure. It's going to establish a pressure gradient, which is going to move the sugars from an area of high hydrostatic pressure to low via diffusion into the sink, where they are then used, the sugars are then used for respiring cells, cell growth in the sink, etc. So let's just have a quick look at what we missed there. Because I'm sure when in the source from the sink, it moves into the phloem, the sugars move into the phloem, and it does something. It might reduce the volume. That might be what it is. It might just be as simple as that. While this is loading up, shall we have a quick look at transpiration as well? I'm pretty sure this process is literally, you have like your leaf, and it is literally water lost from leaf via evaporation, which reduces the water inside the leaf. This causes pressure to increase. and water is going to move up in a column due to strong, so it creates strong cohesion tension. And water is going to move up from the roots in a column. So let's take a look at that to see what we've missed. So sugars, okay, it's not diffusion, it's active transport. That is important to remember. That probably would have been a mark. Active transport out of the source. That is a very important point right there. Because, yeah, that's going to use ATP. This lowers the water potential gradient. Okay, so sugars are, yes, because sugars are soluble. That's going to lower the water potential gradients. So, water is going to move in via osmosis from an area of high to low water potential, creating an equilibrium of water potential. This increases the hydrostatic pressure. Oh, it's turgor pressure, not hydrostatic. Increases turgor pressure, establishing a pressure gradient. Sugars move down the pressure gradient and they are used. Okay, so that is, I think, fairly simple then. So let's quickly recite this. So from the source, photosynthesizing tissues, we have our sugars, which are soluble. From there, the sugar is going to be actively transported out of the source. This is going to reduce the water potential gradient because sugars are soluble. Water is going to move from the xylem into the phloem via osmosis down the water potential gradient. This will increase the turgor pressure, creating a pressure gradient and forcing the sugars to move down the pressure gradient into the sink, where they are then used. And let's look at transpiration. So water, okay, once again, this is due to, and we always forget this, low water potential gradients. So, the leaf evaporates the water. This means there's going to be a low water potential gradient at the top, high. So obviously it's going to move up. This creates tension. So water in the xylem is being pulled up by the column because the hydrogen bonds are cohesive due to adhesion of H2O. Okay, so for these two, the transpiration and translocation, the key idea you need to talk about here is the idea that it's a low water potential gradient, and this is what causes transpiration or translocation. Here, you have your leaf, water is going to evaporate from the leaf, less water, lower water potential gradient. So obviously water is going to move up due to the tension that's created in the water. So some keywords to talk about for this is going to be tension, and the idea that hydrogen bonds move in a column because they're cohesive. Cohesive hydrogen bonds, water moving in a column. Contrarily, here we need to talk about active transport, turgor pressure, pressure gradient, osmosis. I would argue translocation is easier to remember than transpiration. Transpiration, we have our leaf. Let's recite this from scratch. Have our leaf. Water is going to move out via evaporation. This creates a low water potential in the leaf. This is going to create tension, so water is going to be pulled up the xylem in a column. See, it's so difficult. There's a lot of words here that you easily forget. tension, cohesion, hydrogen bonds, column, evaporation. Very difficult process, to be honest. But yeah, water in the leaf is evaporated, so that lowers the water potential gradient, first mark, creating tension, so water in the xylem is pulled up, due to hydrogen bonds being cohesive. So, before we move on, let us have one last look at this process. Let's try and do a couple questions per. So if we were to describe translocation, which can also be called the mass flow hypothesis, I think that's the better name to call it. So I don't know whether this would be a 6 marker. It definitely doesn't feel like one. If it is a 6 marker, it would be a blessing, because that means that you could get piss easy mark points. This feels to me like it would be a 4 marker, where they would be very specific about what you want. So that's my prediction anyways, if we get this. Thing is, we haven't been shown what's on paper 2 or paper 1 of 2024. But when we did our mock, which was for 2024 paper 1, there was no reference to translocation, no reference to transpiration at all, which is reassuring, but we might get it this year. And I want to triple check that, actually. If I go to AQA and check paper 1 2023, will there be anything to do with transpiration? Because that feels like it could be a good bet, to be honest. That could be a good bet to kind of put your money on right there. I might be cooking here. I might be burning. I don't know, but I don't know. I feel like logically speaking, if we haven't gotten a question on transpiration and translocation in a good couple of years, I feel like it has to come up now. Surely I'm not going insane. Let's have a look. Question paper, paper 1, June 2023. So I know 2024 didn't have it. What about 23? Because if it didn't have it in, this could be a very good question to bag. Let's have a look. We got viruses, which would be nice. Chitin and cellulose, that would be a nice question. Trachees, so gas exchange in insects. Describing the Golgi, that would be nice. Antibiotic resistance and natural selection. Oh, I wouldn't have gotten that question. A lot of infection questions for 2023. That is really odd. Quite literally, like 10... Literally, there are 5 questions in a row. There are 6 questions in a row about bacteria in the 2023 paper. That is so crazy. Cancer, talking about enzymes. The ELISA test. Oh no, I would have gotten that. There was nothing on translocation or transpiration. Call me crazy, but I feel like this might come up in this year's paper. If it hasn't come up last year and it hasn't come up the year before, and they talked about the gas exchange of insects last year. Maybe. I might be going crazy. Let's quickly answer this then. Describing translocation. So the sugars are going to move out of the companion cells via active transport. I'm just abbreviating. Please don't do that in an exam. I abbreviate because it's a whiteboard and I can't be asked to write it all. So sugars move out of the companion cells via active transport. This is going to, I guess we should specify they move to the phloem. This is going to lower the water potential in the phloem. So water is going to move from the xylem to phloem down the water potential gradient via osmosis. Again, you always want to hammer in those keywords: water potential gradient, water potential, osmosis, gradient. Literally hammer them in. You might get some marks for it. This is going to increase the turgor pressure, which is going to establish a pressure gradient. So the sugars are going to move down the gradient via the down the pressure gradient, yeah. From the source to the sink, where they are then going to be used by the source. So let's take a look. So I wrote 1, 2, 3, 4, 5, 6 mark points. Sugars actively transported into phloem via companion cells. I said they are moving out. So maybe that's something to know, is sugars move out. Sugars move into. I guess a better way of wording it would be via companion cells, they are going to move into the phloem. I don't know. Lowers the water potential gradients. I guess I should have added there that they're soluble, and that's why. Guess you also could have added the sugars are produced via photosynthesis. Water from the xylem moves into the phloem via osmosis. Yep. This increases the turgor pressure, establishing a pressure gradient. Yep. Sugars move into the sink down the pressure gradient. Yep. And sugars are used or converted into storage molecules. That probably would have been 4 marks. I'm happy with that. Cool. Let's quickly do transpiration, and then we can look at some actual exam questions. Just literally, I just had this on my mind, and now that I've kind of validated myself, I think that maybe this could appear this year. I don't know. I know there's some people that intensely look at the papers. For fuck's sake, hold on. Fuck. Oh. We good? Please. Okay, we're good. Okay, let's quickly do transpiration, and then we're good to leave this topic for now. So, water is going to move out of a leaf via evaporation. This is going to lower the water potential in the leaf. So, water is going to move in a column of the xylem due to the what's the word? Tension. Due to the tension. Don't know how you would word that though. Water is going to move as a column up the xylem due to the cohesion tension, maybe? I don't know how you would word some of this in an exam. The thing is, my brain is very much mark scheme focused. I always write things in bullet points in an exam. I always will, write things as efficient as possible, which means that when it comes to actually describing it, I end up sometimes struggling to write because I'm thinking like a mark scheme. Like, this would probably get no marks in an exam, but I know exactly what I'm talking about. And that's due to the hydrogen bonds being cohesive. So let's take a look. So yeah, 1 mark for hydrogen bonds being cohesive. Tension, okay. Because lowering water potential creates tension. So water moves up the xylem in a column. Xylem is pulled up. It's not moved, it's pulled up. I think we probably would have gotten 2 out of 3 marks there then. Water moves via evaporation out of a leaf, lowering the water potential gradient. This creates tension. So water in the xylem is pulled up due to the cohesion in the hydrogen bonds. Okay. I'm happy, honestly. To be completely honest, I'm happy. I think that went well. Let's look at this 2023 paper then. Let's look at the paper 2 as well. Oh, I've already done this paper 2. Oh, okay. Paper 2, what's one I haven't done? 2019? Feel like I've done this one too. Describe a role of glucagon in gluconeogenesis. What the fuck? Hold on, what? Wait. Glucagon is gonna be... Fuck! Hold on. No, insulin is... Wait. I'm... What? Insulin is getting rid of glucose. That's glucose into glycogen. Glucagon is glycogen into glucose. Wait, what's gluconeogenesis? Is that not converting non-carbohydrates into glucose? I'm neither. So my brain, I can't process this. Attaches to receptors on target cells and stimulates enzymes to convert glycerol and amino acids. Okay, so I was right. It converts non-carbohydrates into glucose. And you had to specifically say amino acids, fatty acids, glycerol. And you have to give the idea that it activates enzymes. Okay, that is a good piece of knowledge to know then. Gluconeogenesis. So gluconeogenesis activates enzymes to convert let's just pick a general example. Fatty acids into glucose. That's it. Easy. Let's try the other ones, because there's some specific names here. There's, I think, is it glycogenesis? And I know there's not glycolysis, glyconeolysis? Glycogenolysis? The names actually get on my nerves, because why do they have to be so similar? I know glycogenesis is it's going to be the activation of enzymes. That's going to be the same mark point for all of them. Activates enzymes that convert glucose to glycogen. I don't remember the other one though. Glycogenesis. That is definitely one, right? Glycogenesis. Oh, my head. Fuck me. Yeah, glycogenesis is the formation of glycogen from glucose. What's the other one? Gluconeogenesis, glycogenolysis. What is that the one we learn? Glycogenesis is that one. Glyconeolysis is glycogen to glucose. So glyconeogenesis. No, neolysis. But see how confusing these names are? So it's going to be, again, activating enzymes that break down glycogen into glucose. Okay, there has to be an easy way to remember this. Gluconeogenesis is easy to remember because it's the only one that starts with gluco. And that activates enzymes that convert fatty acids to glucose. Glycogenesis is the genesis of glyco. Glycogen. My brain actually stopped for a second. Oh my god. And glyconeolysis is the lysis of glycogen. Okay. That should be fine then. Just look at the beginning and the end of each one. Glycogenesis is the generation of glycogen. Glycolysis is the lysis, hydrolysis of glycogen. Glucogenesis is the generation of glucose. Right, that's easy then. That's easy. Look at the first bit and the last bit. Remember, it's always the activation of enzymes. It's always the activation of enzymes. Cool. That was a very well worth bit of information. Explain how... no. Oh no, it's a genetic diagram. A heterozygous grey-bodied, white-eyed female fly was crossed with a black-bodied, red-eyed male. So... grey body is G. Black body is G. Red eye is R. White eye is R. Immediately thinking, is this going to be the 1 to 2 to 2 to something ratio? Heterozygous, grey-bodied, white-eyed female fly was crossed with a black-bodied, red-eyed male fly. So, heterozygous grey-bodied, so that's going to be G R crossed with a black-bodied white eye. Okay. Oh, I sometimes hate biology. Purely because of his subject here. There's probably an easier way to work this out, but I guess we're doing this method. GR 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 GR. Probably a mark. Okay. G G R R G G R. This is gonna sound like I'm going insane, guys. I'm not. I promise. Wait, we can just repeat. Is this gonna be a 1 to 2 to 1 to 1 to 1 to 1 ratio? Wait, but is it asking for gender too? Because if it is, it's going to be a 1 out of 8. If it's asking for a specific genotype, it's going to be a 1 to 1 in 4. That is going to be a 1 to 1 to 1 to 1 ratio. It is asking for genotypes of offspring, phenotypes of offspring. Show all the possible genotypes and the ratio of phenotypes. So the genotypes of offspring is going to be big G, low G, big G, low R. Oh my god, I can't speak. Big G, little g, big R, low R. Big G, little g, lower R, lower G. You get me. That's going to be that. The phenotype of that is going to be grey body, red eyes, grey body, white eyes, black body, red eyes, black body, white eyes, and it's going to be a 1 to 1 to 1 to 1 ratio. Please, if I don't get that right, I might actually start sobbing. No, because it's a fucking no. No, I didn't read the question properly. No, fuck you. Fuck you. Fuck right off. R is located on the X chromosome. Of course it's located on the X. Fuck off. Okay. So that means it's actually going to be XR. No, I don't want to do this again. Huh? Because that changes everything. That's going to be X. Is that a female or a male? Female. A female is XX, yeah. Oh no, that would have made everything more complicated. So then, is the ratio still 1 to 1 to 1 to 1 to 1? So actually, I didn't fuck up a question that badly. Probably would have got no marks, but I didn't fuck it up badly. All I would have needed to do was literally just replace... honestly, if I didn't misread the question, that would have been the easiest 3 marks of my life. And that took, what, like 5 minutes to do? That would have been the easiest 3 marks of my life. But I'm stupid. Population... Oh, no, not the fucking Hardy-Weinberg equation. Fuck you. Population of fruit flies contains 64% grey-bodied flies. Use a Hardy-Weinberg equation to calculate the percentage of flies heterozygous for gene G. Right, let's have a look. Population is 64% grey-bodied. Grey body means that they are either GG or GG. This is Hardy-Weinberg, isn't it? Calculate the percentage of flies heterozygous for gene G. So, altogether, this is 64%. I've literally fucking done a question like this. And I don't remember how to do it. Oh no. Right, I'm gonna slightly cheat and just look at what the Hardy-Weinberg equation is, just so I can remember. It's squared. So that's going to be G squared so is it not going to be the square root of 64, which gives you 8? Can we just put 8 and get a mark? Nope, the answer will be 0. The answer, right, is 48%. 48% is heterozygous. Let's figure this out. Let's figure out how you get to 48%. Let's figure out how you get to 48%. That is obviously going to be 36... No, yep. Yep, 36%. So... I don't know. We literally spent, for those who don't remember, we spent 3 hours on this question last time. Couldn't find out how to do it, and it was so obvious. It's asking, you're given the frequency of an allele. Right, let's just cheat. Fuck this. Square root of q squared Oh, because this is 2g. Use square root q squared, so that's a recessive. 1 minus 0.6. So, am I right in doing the square root of 36 as 6? And that gives you the percentage? But then that would only be 58%. Where are you getting 48 from? No, I'm actually going to start spiraling again and spending like an hour trying to get this right. I'm so confused. Why is this equation so stupid? Am I actually being fake? I feel like I'm being fake and this is the most obvious thing ever. Am I being fake? Is there something I'm not seeing? Right. No, wait, I'm actually gonna start spiraling again and spending like an hour doing this. Right. I'm spending no more than 5 minutes trying to understand this before I give up. Right. Hardy-Weinberg equation is p squared plus 2pq plus q squared, where p squared is homozygous dominant, 2pq is heterozygous, and q squared is homozygous recessive. We know that, right? We know that. That's how it works. Equals 1. It's saying a population of fruit flies contains 64% grey-bodied. And grey-bodied is dominant. So we know that P in this example is going to be the dominant allele for G, grey-body. It's dominant. So, by that logic, 64%, because it's dominant, has to be that whole section there. Which means the black body is 36%. And what's it asking for? The percentage of flies heterozygous. So, am I right in thinking that obviously 36% can't be heterozygous at all because they're going to be recessive? So we are only focusing on this group of 64%. How do you calculate from there? Do you divide by 2 and then square root? No, because that gives you 5.65. What? What am I missing? Oh, what am I missing? I'm so confused. I have to be missing something. Okay, well, it's given you a hint. And that hint is 1 minus p squared plus... Okay, this might help. 1 minus p squared plus q squared. That's the amount of heterozygous. So by that logic, 1 minus the square root of 64 plus the square root of 36 minus 13. Because we don't know what p squared is. Oh, what the fuck? Accept understanding of 2pq by using a calculation involving 2 times 2 different numbers. I'm so confused. This is literally what we spent an hour and a half doing on one stream, and I still couldn't figure it out until I ended the stream and watched like an hour worth of YouTube videos to figure it out. In an exam, is it really going to be worth wasting 2 marks on the Hardy-Weinberg equation? Right, no, I'm starting again. I'm starting again with this stupid equation, and we're gonna figure it out. 64% are grey-bodied. Last time I remember drawing a Venn diagram. I remember. I don't know if it helped, but we were able to gauge the idea that 64% are here, 36% are here. So what does that mean about... That has to be 6. 6, 2 times p times 6. But obviously this is going to be in integers, so 0.6, 0.6. Wait. So, let's just put d squared on the calculator, plus 2 times d times 0.6 plus 0.6. Sorry, 0.06. Saying d is 0.91, that makes no sense. Hold on, but we have to be close. This has to be how 2 times p times 0.06. Because we know q is 0.06, because we know that q squared is 0.36, or 36%. So we know I don't understand. Because what about me but 94% is? Two times p times 0.06 plus 0.36 equals 1 plus p squared. Just need to figure out what p is. Wait, no, that means I put it in the calculator wrong. D squared plus 2 times d times 0.06 plus 0.36 equals 1. 0.742. And the correct answer is 48%. Where are you getting this from? Where? What? Why is this equation actually driving me fucking insane? Why can't I do the Hardy-Weinberg equation? Why am I doing fucking A-level math in order to try and figure this out? $64%. That's gonna get you 58%. Yeah, I'm giving up. I'm giving up on this question. If Google can't tell me what it is, then I am never touching Hardy-Weinberg again. If 64% is grey, then p squared plus 2pq is 0.64, and q squared is 0.36. Solving for q, we get q is 0.6. Wait! But I thought q was 0.06. No, because that's not how fucking decimal... Oh my god, I'm a tit. Right. No, I might be getting somewhere now. Hold on. So p squared plus 2 times p times 0.6 plus 0.6 is 1. Since p plus q equals 1, p plus q equals 1? What? Where did that come from? What do you mean p plus q equals 1? Have we not been taught this properly? Have we not been taught the Hardy-Weinberg equation properly? Because what does it mean p plus q equals 1? Because if that's the case, then p must be 0.4. But then what do you do from there? 2 times 0.6 times 0.4. And that gives you 0.48. What? I'm so confused. Have we been taught this incorrectly? Or am I literally severely misinterpreting the question? Am I severely misinterpreting how to do this? That question cannot be that difficult for 2 marks. Can't figure out how to get the answer. I know how to get q is 0.6. I get to that point. So then just p plus q equals 1? I want to try. I want to try another Hardy-Weinberg question. To see if I'm being utterly thick or whether we have been taught this wrong. Because it tells us, okay, it tells us here that p plus q equals 1. And then it tells us p squared plus 2pq plus q squared is 1. I want to do one question on this, and if we get it wrong, then I'm leaving for the day. Okay, sea otters are close to extinction. The dominant allele T codes for an enzyme. The other allele T is recessive and does not produce a functional enzyme. Okay, let's try this one. In a population, the frequency for the recessive allele T was found to be 0.2. Frequency. So, we are given that 2TT plus T... You get what I mean? Okay. We are given that the frequency for that is 0.2. That means the frequency for that must be 0.8. Which means 0.8 squared. This can't be right already. I can't be doing it right then. Because why would they make these numbers this difficult to understand? Oh, what the fuck? 2 marks for correct answer of 4. The other allele T is recessive. Dominant allele T. The frequency for the recessive allele. Wait, so that whole thing, because it's just on about the recessive. Right? Or am I once again misinterpreting this type of question? Because it overall wants to know what t squared is. And we're saying 2tt plus t squared is 0.2. So t squared must be 0.8. That means 2 times the square root of 0.8 times t plus t squared is... What the fuck? No, I'm giving up. I don't know how to do the Hardy-Weinberg equation. I'm gonna go smash my head in with a hammer. See you guys.